Hi class, this is our fourth online lesson and our third in the series of dynamics. In the morning we studied about connected particles. This is the same thing. The only thing is now the particles will be connected and will pass over a pulley. See, in our M1 syllabus, the pulley will always be smooth. We will never have a question with rough pulley. So since the pulley is smooth, the two bodies as the assumption is the two bodies will have the same tension, the string will have the same tension, and the acceleration of the two bodies will be same. Let us take our first example. Now it's a big example and all the questions now are big, and this is what you will see in exam. If you look at this, it's 7 plus 3 10 plus 4 14 marks question. Okay, so pay attention now. See, they have drawn a scenario for this is the pulley. These are the two particles P and Q. The question says two particles P and Q have masses K, M and 3M, where M is any unknown respectively. They're just saying that K is smaller than 3. This is smaller in mass compared to Q, the mass of Q. The particles are connected by light. Again, light is no, we can assume the mass to be 0, inextensible. Same what we just studied. String passes over a smooth, again smooth, light, fixed pulley. The system is held at rest and the string is taut. Taut means not slack. It's straight, you can say. Without slack, it is means taut. The hanging parts of the string vertical and with parts of the string vertical and with P and Q at the same height above the horizontal. So this P and Q are, let us say somewhere here is the ground, they are on the same side, same height horizontally. The system is released from rest. After release, Q descends. Now Q is descending down, so Q is down, and because they are connected and there is a pulley, obviously while Q goes down with the same acceleration, P will go up. Okay, so this is the question. They're asking us to find the tension in the string. Remember, this is the same single string, so tension will be same throughout. And remember, tension will always direct towards each other. In the next slide, I will show the diagram with the missing masses, missing forces, I mean. And the second part, they want us to prove that this K is 1.5. The third part of the question says, state how you have used the information that the pulley is smooth. Now, because it is smooth, there is no friction, so the magnitude of acceleration of P is same as the magnitude of acceleration of Q. So they are moving with the same acceleration basically. Okay, so I just took C first. Let us go through part A and part B. Part C we'll discuss in the next slide. Okay, so if you look at this was the diagram given in the question. Obviously there are unknown forces. There are forces here which are not mentioned, but obviously the forces are there. You have to draw. See, because this is a mass, it will always have a weight acting downwards vertically down. So this is the weight, mass is Km, so Kmg. This is 3m, so weight will be 3 mg, and the tension, remember, tension always points towards each other, so both will be pointing upwards. So there is a tension here, there is force here, there is a force here, there is a force here. This is accelerating up, the acceleration is given 1 by 3 g 9.8, and this is accelerating down. Now if you look at, and same like we studied in the morning, you can take particles P and Q individually. You can take the entire system as one system depending on the requirement. Now for Q, if we take downward as positive, and the same thing, the resultant force equals to mass into acceleration. F equals to ma. Resultant force at Q, see, because it is going down, so this force will be positive, T will be negative, this positive, T negative. Mass into acceleration, this is the mass, acceleration is given, and so we get T is 2 mg. See, because we don't know what is m, you cannot find the answer as a number now, so we just leave it to m. G is obviously 9.8, but we leave it to mg. This is the tension. Now if I take P, this force, this particle P here, and because it is going up, we'll take up as positive, so this tension will be positive, Kmj will be negative. Again, force, the resultant force is mass into acceleration. You just substitute the information here. This negative actually goes on the other side, becomes positive, this goes on the other side, and you get, basically you simplify all of this, you get the value of K is 1 point, and this T we already have from here, 2 mg. You substitute there, it's 2 mg. Simplify this, you get the answer. And this was actually a proving question. The question was show that K is 1.5, and we proved it. Now the answer for part C we already discussed. Let us go to part D, and this is, see, part D is now the tricky one. The question says, after descending for 1.8 seconds, the particle Q reaches the plane. It is immediately brought to rest. So Q reaches the plane, the ground. This Q reaches the ground here and immediately is brought to rest by the impact. Okay, the initial distance between P and the pulley is such that in the subsequent motion P does not reach the pulley. This is just trying to tell you, while Q reaches the ground, P is not touching the pulley. P is somewhere here. Okay, show that the greatest height in meters reached by P, the greatest height reached by P is 1.26 G. We leave the answer as G, where G is 9.8. Now, what is important here is, see, when Q moves down, the same distance P will move up. This is obvious, correct? So whatever distance Q moves down, the same distance P moves up. So this distance and the same distance, so I can say whatever is this distance, P will be at twice that height. But a very big misunderstanding here is, students think that's it, this is the final height what P can reach, but that is not correct. See, while Q has reached the ground, in the subsequent motion, let us say when Q reached the ground, P has reached here. Now when Q stopped, definitely when Q stopped, P is still in motion, P still have some energy. P will not immediately stop. P will go a certain distance up, but this time it is not connected with G, so it will not be under the same acceleration. That small distance that it will move up will be under gravity. So it will move, P will go, P is already at this height, it will go that same height up and little more. Let us discuss that here. Taking up as positive, while Q is descending, the distance traveled by P, let us say it is S1. Now because we know it is starting from rest, they gave you acceleration, they gave you time, you can use simple kinematics, substitute, you get the answer. S is 0.54 G, and because we want answer in terms of G, we leave it like this, we don't substitute here, 9.8. Now this is S. At the same time, use the same information to find V also, because when Q reaches here, the velocity with which the velocity of Q when it reaches the ground will be the same velocity when P reaches here at this point, correct? And now from here P is going little more up, so that V, which is 0.6 G, for this motion, see what I'm pointing here, that V will now become U, so that U is V1, which is 0.6 G, and finally when it reaches maximum height, the velocity will become 0. It is now going under gravity, so acceleration is negative 9.8, and we'll find S. We substitute in this formula, you get S is 0.18 G. So basically what we understand here is, when Q moves down, when it reaches the floor, P has gone that much distance up, okay, which is 0.54 G, and then it has gone little further up under gravity, which is 0.18 G. So what is the total distance that P is above the ground? One is this distance which it is already above the ground, then it will go the same distance up, so it is double that plus that 0.18. So it is double of this plus 0.18, double of this plus 0.18, and hence we proved that it is 1.26 G. And see, that is why this question was 7 marks and it is worth it. That's it. We'll take the next question now. See, by now you understood the concept, so I want you to pause your video here, read the question carefully and try to solve this question. Okay, when you are ready, you can start the video. Okay, I hope you have already tried. Let us look at this question. It's a very similar situation. There's a particle moving through a pulley. There are certain forces which are not drawn, so there will be a weight here, 3G. The weight of A will be also acting downwards, mg, tension moving upward direction in both sides. And again they are saying this is greater than this, so that we know this will go down, so it is descending down with the same acceleration. P is moving up. Now the question, okay, the particles are connected. Okay, initially A is 2.5 meter above the horizontal ground, so this, which is marked here in the diagram also. The particles are released from rest with the string taut, the same word, and the hanging part of the string vertical as shown in the figure. After A has been descending for 1 point, see again we know S, we know time. It strikes the ground like the previous question. Particle A reaches the ground, B has not reached, like the previous question. They're just trying to tell you that when this reaches here, A is still somewhere here, it's not touching the pulley. Now the question says show that the acceleration is 3.2, so we have to find the acceleration first. Then we have to find the tension in the string, and then we have to show that the mass m is 65 by 11, okay, and then the assumption which we know, and the last part of the question we'll discuss later. Let us talk about this now, the first three parts. Okay, see, I'm not going to a new slide so that you can see the question and we can understand here. For the first part, they gave us the S, they gave you U is initially 0, we know time, simple kinematics, S equals to ut plus half at square, you get A is 3.2, we proved, we got 3 marks. Find the tension in the string now. Again, I'm just taking for B, if I resolve for B, taking up as positive, remember there will be a force tension up and the weight down. So because you're taking up as positive, T will be positive, 3G will be negative. So this is your resultant force equal to mass into acceleration, F equals to ma, the same thing. So mass is 3, acceleration, so we just simple algebra, it's 3 times this, you know A, you substitute A here and you get 39 Newton. So we know the tension is 39 Newton. Okay, let us show that the mass is 65 by 11 now. Now we look at A. So for A, again, because it is going down, we take down as positive. So it will, the weight mg will be positive, tension will be negative, is mass into acceleration. Again, F equals to ma. So T is m times, you just rearrange, take the mg on the other side, 6.6. Substituting for T, we know the tension is 39. You just substitute 39 here, you simplify, we got 65 by 11 as required, hence proved. Now let us take this last part of the question and let us read it carefully. The question says, when A strikes the ground, it does not rebound and the string becomes slack. So again, when A strikes the ground, okay, it is not rebounding, and the same distance that A goes down, B will go up. So B will be, let us say, somewhere here where I'm pointing now. Now, particle and then rebound string becomes slack. After that it will become slack. Particle B then move freely under gravity exactly like the previous question without reaching the pulley until the string becomes taut again. Find the time. Say in that previous question they were asking us to find the total distance. Now they are asking us the time between the instant when A strikes the ground and the instant when the string becomes taut again. See this thing, I've made a nice diagram. In the next slide you will understand what the question is talking about. See here, so when A has reached ground, let us say B was here. Okay, now again like the previous question we just did, this will go slightly up under gravity. So this, and it will become slack. You see I've shown slack here, and definitely it will come back and it will become taut again. So it will go this much up and then it will come back same. So it will take some time to reach there and some time to come back. So it is double of T. Basically we just have to find T and then multiply it by 2 till A hits the floor. Now we know initially it was 0, they gave us this, they gave us acceleration, V, just put in simple mathematical formula, V square is U square plus 2AS, you get V equals to 4. Okay, and then B with U equals to 4 moves under gravity. Now like the previous question, the same V now becomes U. Okay, so first we were finding this is for the part when B was going up, and now it will go slightly up, further up. So for that, this we wanted this V actually so that we can use it here. So while this is going up, like in this distance where I'm pointing now, your U will become 4. V definitely when it reaches this maximum height here, velocity will become 0. It is under gravity, so minus 9.8. Substitute in the formula and you get 40 by 49 second. This is the answer. Next, we doubled it, we multiplied by 2 because it is going up and coming back there. This question will be your task. Now you will do this question again. It's the same thing, same scenario. What I have done now, I have the forces which are not drawn for you. So you go through this question, read the question. I have drawn the forces for you to make it easy. Next slide. You see I have made all this whenever it is under acceleration, motion. You have to use F equals to ma. I have made this diagram. Things are here. Try to do this on your own, and then we can discuss the doubts later. That's it. Goodbye.